This is a course project for MSE 352. It's a third-year digital logic and microcontrollers course. Our group consists of Vadim, Sid, and Ramil. So there's two parts of the project. One is an LED board which can display characters, and the other part was an animatronic robot which can be controlled by a joystick. So the way the LED board works is it's being driven by row scanning. So each row is switched on for a very small time, and the data is fed through the columns. The data is being fed through the microcontroller, which is ARM Cortex M4 processor. The shifting is done using shift registers on both the row side and the column side. The data is being fed through the column side, and all the text is hard-coded into memory of the software. And any text can be displayed, any ASCII character can be displayed on the board.
Use a joystick.
So the original idea with the bird and the board was that the bird would stand in front of the board, and as random LEDs light up, you would control the bird with the joystick and peck the seeds, so to say. After which the seed would disappear, but that just exceeded the time limitations that were put above us. So what we have here is a acrylic model. All shapes are two-dimensional. The design was created in SolidWorks and then laser cut, and was very easy to put together. It contains 3 servos. 2 of them are aware of their position. This last one is only aware of how quickly it's spinning. It's a continuously rotating robotic servo. So the neck extends using a lead screw. The pitch and yaw are directly controlled by the servos. So a nifty little assembly. So the way the servos are controlled is using an analog voltage that's coming from this joystick, so 2 potentiometers. The value is then sent to the microcontroller, where it goes through an ADC converter. The converter is triggered every 5 milliseconds by an interrupt timer, after which the corresponding PWM value is calculated and the bird can be in motion. The sort of software package also features a UART interface. There's certain things you can do on the computer. In our case, very simply, you can see it's actually quite large. You can see the current character being printed, and then on demand it can calculate the voltages, the PWM pulse width in microseconds, and the duty cycle, as well as the analog voltages that go to the joystick. And we can see that if I move the bird a little bit, the pitch will now change from 7 to 4.
Perfect.
So that's about it. Thank you.
Thanks.